I'd now like to welcome to the floor Gordan Lauc, Director at the Human Glycome Project, as well as Director of the National Center of Scientific Excellence in Personalized Healthcare. Gordan will be sharing with us insights on how slowing glycan aging might be a critical key for modulating inflammation. Gordan, pleasure to have you back. The floor is yours.
Good. So can we slow down or can we even revert glycan aging and in this way stop inflammation? So we all know that inflammation is one of the main drivers of aging and age-related diseases. And slightly over a year ago, this was a headline story of the New Scientist where they said you're only as young as your immune system. So we have to think about our immune system. And if we think about our immune system, then glycans are extremely important. Glycans or circulating immunoglobulins are functional effectors. So they're parts of the molecule which are balancing inflammation and also inflammaging. And depending whether we are young or old, we would have either glycans which suppress inflammation, or when we get older, we have glycans which promote inflammation by multiple interactions. There is a very good review here if you're interested in details. I will focus more on glycans because they're the ultimate layer of molecular complexity. So practically nearly every protein which evolved after the appearance of multicellular life is glycosylated. It has these furry modifications on its surface. They're called glycans. They have nothing to do with the glycation, HbA1c, AGE. So this is something completely different. Please do not mix glycation and a glycated hemoglobin with glycans. So glycans are modifications which modify protein function. They take part of the structure. They act with to interact with the receptors. This is S-glycoprotein of the SARS-CoV-2 virus. But unfortunately, glycans are the most neglected molecules. People ignore them because they're difficult to study. And even the director of NIH was writing about the S-glycoprotein, so this molecule here, without a single glycan on its surface. They do it because it is difficult. It's not easy to look at glycans, but we started the journey over 10 years ago. We analyzed over 150,000 different individuals, but not any individuals from some of the best phenotype, genotype cohorts in the world in collaboration with some of the leading researchers. And now we can combine this glycan data, which we generate, with everything else they have collected in these biobanks and learn a lot about functions of glycans. And the first thing we learned is that glycans are fantastic biomarkers of biological age, not chronological, because you don't need a biomarker to know how chronologically old you are. But for biological age, they're very important. We got over 15 million euro of research grants, studied over 100,000 people, and established this glycan age biomarker, which is now commercialized through a London-based startup called Glycan Age. So the key benefit of glycan age is that it is actionable. So the main disadvantage of the majority of different aging clocks is that you do things which you know they're healthy and your clock does not change. This is particularly the case for the original Steve's epigenetic age clock, because this is just measuring more or less your chronological age. But most of other epigenetic clocks, and now there are dozens of them on the market, also do not respond well to different interventions. So you change something and then your clock does not change. We try to make glycan age really hard science. We published over 100 papers, some of them in the leading journals, including a number of Nature journals, Gastroenterology, which is the leading gastroenterology journal, Circulation Research, and so on. And through all these studies, 100,000 people, over 100 publications, we learned that glycans change a lot in the diseases. And in the majority of diseases, although these are very different diseases like cancer, diabetes, inflammatory diseases, people who are ill will change in the direction of aging. So these last 4 bars, this is just effects of age. There are some glycans which go up. These are the pro-inflammatory glycans. glycans which suppress inflammation, they go down. And people with a disease, they look similar to healthy people, but who are much older. And often this actually happens before the disease develops. Because if you remember from the beginning, these glycans are functional effectors. They're molecular drivers of inflammation, and inflammation is underlying many chronic diseases which are burdening the society today. So the big picture is, can we prevent, can we postpone these diseases by acting early enough? Because what normally happens is that people go to hospital when something stops functioning. When you have pain somewhere in your organism, you go to the hospital, you get a diagnosis, but this is beyond the point of no return. Usually, these chronic diseases are chronic because you can't cure them. So you stay with the disease, you are just trying to take care of the symptoms. But this is not 1-0 transition. It is not going from healthy to being ill tomorrow. This is a process which takes even over a decade, where first there are molecular drivers, which are then compensated, and things are losing their compensatory power, and eventually you end up ill. But if we act early, if we find these drivers, while a simple preventive lifestyle intervention, maybe something what was shown in a previous presentation, just a weight loss, can change them, or maybe early pharmacological intervention, then we can prevent or postpone disease. So this is kind of a big picture, and glycans are here very good markers because they very often change before any other disease symptoms. And for example, one of the examples is this pandemic that we are now still living in. The major risk factor is age. So old people get severely ill, young people generally don't, but it's actually biological age which is the main driver, not chronological. Because often what we see when we see the young people being severely ill, these are the metabolically frail individuals. And on a figure, this is the youngest victim in North Dakota. She was only 17, and definitely you can see that she was not healthy. Although obesity is now accepted as normal, obesity is not healthy. And we have to think, what can we do to improve our health and then avoid severe consequences? And our studies have shown that people with older glycom have a higher chance of developing the severe COVID-19, and unpublished, but very soon to be published, also people who will have a fatal outcome. They're changing their IgG glycom much faster than people who will have less severe consequences of COVID. And this is something what David Sinclair and I published over a year ago in our editorial in Aging, where we said that actually it's the biomarkers of biological age we should be more predictive, because, and then the glycans are very good example here, because they integrate genetic, epigenetic, and environmental factors into a simple index which can be quantified. You can take out the molecules, you can cut them off, you can label them, you can measure them, and you can see what is the current situation. But COVID is just one of the examples. I think the most prominent example we have found are the cardiovascular diseases, where in our initial study published a couple of years ago, we studied over 3,500 people, and we showed that IgG glycom associates with the cardiovascular disease the risk score, so the risk of future cardiovascular events. In a second step, we analyzed the prospective study, 20,000 people, blood samples collected 30 years ago, followed up clinically. We knew who will and who will not develop the heart attack or stroke. Look at the glycans, and glycans were as predictive as the entire AHA score, and in women, only a single glycan was more predictive than the entire AHA score. The mechanism is probably by driving hypertension, because we showed that the glycans change before the hypertension develops. And in animal models, we actually showed that this can be prevented. So if mice are fed high-fat diet, they become obese. Their glycans on IgG lose sialic acid, they look older. And if you feed these mice with a MANAC, which is a dietary supplement, which is a precursor of sialic acid, then the mice do not lose this sialic acid. They do become obese, but they do not develop hypertension. So by feeding a dietary supplement, you can repair glycans in the mice. and save them from developing hypertension. This is mice. We don't have a data in humans. In humans, we have only correlation data so far. Another very good example is the menopause. On this figure, you can see the changes of glycans in the different cohorts. These are 5 large cohorts in Europe. Blue are men, red are women. Men are changing mostly linearly, but while women have this bump around the menopause age. And what we actually see on an individual level, that, for example, a person who would have very good glycan age for years rapidly deteriorates. And this actually happens before any other symptoms of menopause occur. And then if you give a proper hormonal supplementation, this goes back again. So the idea is maybe women don't have to wait until all the problems develop. If they see just a change in a biomarker, they can start the therapy early and avoid this perimenopause problem, which is a currently clinically very severe problem because there are no biomarkers. So, key question of today, can we revert it? Is there something we can do to change our glycans and prevent age-related diseases? Anecdotally, we have a lot of data. So with Joe in New York, he has over 150 people in his praxis taking glycan age regularly, checking glycan age regularly. In principle, in everybody we see that it improves with appropriate therapy. We are seeing the similar things in Europe. This is Tim Spector, professor of genetic epidemiology in London. He was good for a long time, then the glycan age deteriorates. He decides for a lifestyle change and loses 11 years in 8 months. If you're interested how he did it, there is Instagram Live here, which you can look. But this is anecdotal. We are really trying to do hard science. So we are looking for cohorts where people have actually done a study with a placebo control. So this study is a hormone intervention where the menopause was chemically induced, and then half of the group was receiving a placebo and half of the group was receiving estrogen supplementation. What happened? Women on placebo aged on average 9 years in 6 months, while those taking estrogen, this did not happen. And women who were initially very good in their glycan age, they changed the most. So actually, this is exactly the example which I have shown previously. So hormones work. Weight loss works. So we did a couple of bariatric surgery cohorts, and bariatric surgery is very effective in rejuvenating the IgG glycome. We have even had a patient improving for 37 glycan years in 6 months. Of course, not everybody changes for that much. And again, bariatric surgery is maybe too drastic for most of the people, but even the regular weight loss seemed to be working. We analyzed 2,000 twins in 3 time points over 15 years. And we have shown that the twins who were gaining weight were actually aging faster than twins who were losing weight in the same period. But as Jeremy said, in the last lecture said, there is no magic diet which works for everybody. We are all different and we all differently respond to different food. This was a study on 1,000 people on 5 different diets. And what we can see that on each of the diets, some people went up, some people went down, and this is way more than what we normally see in people who are not changing their diet. So there is no magic cure for this. You have to check and see what actually works for you. Even for some people, low protein, high glycemic index was good. The same for exercise. You cannot sweat out bad diet. Generally, people overtrain, and what we see negative effects. Too much training generally promotes more inflammation and the glycan age gets worse. Each of us can find an optimal way of training to see what is the best for them. Microbiome, extremely important stuff. So what you eat is changing your microbiome, and then your microbiome is affecting your glycome. Again, very individual. There is a crosstalk between the glycome and the microbiome, and the microbes respond to what you eat. Microbes bind to your gut glycome, and then microbes affect inflammation, which affects the glycome. So there is a very important interaction with the microbiome and a glycome. There are many, many research studies showing the links between glycans and diseases. We recently published a very good review. This book is extremely expensive, over 3,500 euros, but our chapter is freely available. You can download it here. If you're interested, I can email it to you. So to slowly bring this presentation to the end, what is the big picture behind it? What is the idea? So the idea is that we can try to motivate people to live healthier and to prevent diseases. Because in principle, we all know what is healthy, but we don't know whether this is healthy exactly for us. And also we find it hard to motivate ourselves to do something today which will benefit us in 10, 20, 30 years. So we need kind of a faster feedback whether what we are doing is good or whether what we are doing is not good. And the markers like 𝐁 can give us objective insight into something what we cannot see in the mirror. And the 𝐁 can give us objective insight into low-grade chronic inflammation. So much of this low-grade chronic inflammation we have. And this is a quantitative tool which can help us evaluate effects of different lifestyle intervention. So we try something and we see whether it works. And often I get asked, why would I do a 𝐁? I'm afraid, I don't want to learn that my 𝐁 is bad. And the answer is simple. The soonest we learn that something is bad, sooner we can try to fix it. So one should not be afraid of having a bad 𝐁 at the beginning if this can be corrected. And as I mentioned, this is already in the market. Of course, I'm in a conflict of interest because I'm one of the founders. So you have to judge the facts by yourself and don't have to listen to me. But this is something which you can do. You can go to the website, you can buy it, you can test it, and you can see how your glycans look today and what will happen with your glycans in the future if you change something in your lifestyle. And at the very end, I have to acknowledge that our research has been funded with over, now it's 22 million euros through different European and national and some NIH projects. And I have to gratefully acknowledge their funding. And I thank you very much for your attention.
Thank you so much, Gordan. Very insightful as always.